Okay, so this is a calculation. He wants us to calculate the atom economy for the production, it says here, of sulfur dioxide. So sulfur dioxide is this chemical. So that means this is the desired product. So if you remember the equation for atom economy, it is the mass of the desired product, which in this case is the mass of SO2. And it tells me here that SO2 has got a mass of 64. And then we divide it by the total mass of all the products. So in here, we have got two lots of copper. So if I come up to here, copper is 63.5. So I've got two lots of 63.5. And then I've also got to add the sulfur dioxide to that as well, because that's also a product. And then that whole thing gets times by 100. So if we just work that out, 2 times 63.5. So that's 127. And we're going to add to it the 64 plus the 64 is going to give me, plus 127 is going to give me 191. And then that is 64, and it's going to be times by 100. So we've got 64 divided by 191 times by 100. So 64 divided by 191, and then multiply the whole thing by 100. And that's giving me an answer here of 33.507. But just check, because it wants to give me to two significant figures in my answer. So if I come back down here, there's the first significant figure, there's the second. This one here is greater than, is 5 or greater. So that means my answer is going to become 34%. In terms of marks, there's 4 marks in this question. Wow, it's taken a lot of marks at this. So you're going to get a mark for working out the 191. You're going to get a mark for putting kind of these numbers in the right places, a mark for getting that, and then a final mark for getting the answer to 34, two significant figures. Okay, based on the position of vanadium, which row shows most likely colour? What we need to remember here is this is in the central part of the periodic table. That means it is a transition metal. Transition metals have high melting points, and they are also coloured compounds. There's my core knowledge. So the melting point for A is 50, so it's not going to be A, and the melting point for C is 50, it's not going to be C. B has a high melting point, which is fine, but it's a white coloured compound, so it's not going to be that. D is a high melting point and it's orange, so it's coloured. So the option D is going to be the correct answer. Next one, calculate the mass of sulfuric acid. So I'm going to put some question marks underneath that. I want to find the mass of that. That could be formed from 400 tons of sulfur dioxide. Let's get rid of that there. So what I'm going to do first of all is I'm going to work out the moles of the sulfur trioxide. So according to my Mr. Moles triangle, moles is going to be mass divided by the MR. The mass is 400. The MR tells me here is 80. So I've got 400 divided by 80. Let's stick that into my calculator. 400 divided by 80 is 5 moles. Okay. And if you just check the ratio, the stoichiometry, I'm going from here to here. So the ratio is exactly the same. It's 1 to 1. So let's put a little separator in here. So now what I want to do is work out the mass of H2SO4. So the mass is going to equal the MR times moles. The MR, sulfuric acid this time, is 98. The moles is 5, so times that by 98. And that's giving me an answer of 490. And the units will be tons. because the first one was also in tons. Marks wise, there's 2 marks there. So 1 mark for working out the 5 and 1 mark for finishing off to 490. Okay, next one is calculate a percentage yield. Remember, the equation for percentage yield is the mass of stuff that you want or that you got divided by what you could have got. So we're told both of these numbers in the question. We're told it says it was calculated that 700 tons could be made. So we could have made, in theory, 700 tons, but they actually made 672. And I'm going to multiply that by 100. So we've got 672 divided by 700, and then multiply the whole thing by 100, and that's going to be 96%. So there's 2 marks in there. You're going to get 1 mark for putting these in the right place, and then 1 mark for finishing it off in that way. And the last question, you always tend to get this question whenever you get a percentage yield. It then says give reasons why this is less than 100. And what we need to include in here, and I'm going to give you 3 reasons because there are 3, but you only have to put 2 in your answer. So you get incomplete reactions is fine. You could also say you get unwanted side reactions. So the chemicals should react as the equation shows, but sometimes they go off and do different things. And the third reason is you could get loss of chemicals during the practical. As I said, you only need 2 from that list, but any 2 from that list will get you the marks.